Mohamad is a chief technical officer and leads the technology vision for his company. After spending 20 years in ICT infrastructure, cybersecurity, ICS, systems design, and project management experience, Mohammad's unique ability to understand cybersecurity requirements in industrial control systems environments enables ATS to stay at the leading of technology. So please put your hands together and welcome Mohamad Aboulniaj. Good luck.
Thanks, Sam. Hi, everyone. So the agenda for today's presentation, why it's important to secure industrial control systems or operational technology, what are the challenges that the operational technology owners and operators are facing, and what are the best practices on how to secure the industrial control systems. So why it's important to protect industrial control systems or operational technology? Because attacks, cyber attacks targeting those critical infrastructure facilities happened already, and they are happening, and they are going to happen in the future. We can see tens of reported incidents targeting the operational technology infrastructure. Many of them are really reported, if yearly, it become monthly nowadays. I wanted to talk about, as an example, about the colonial gas in the US, but I believe my colleagues explained well this incident. So I want to give another example, which happened also earlier this year. There is the Oldsmar water treatment plant in San Francisco. It is a drinking water supplier for more than 50,000 consumers. Earlier this year, one of the operators noticed that the sodium hydroxide ratio was increased by 100 times, only by seeing his mouse moving alone on the operator workstation and playing with those ratios. So only coincidence led to find this issue and prevent the supply of such poisoned water to people. So in regular IT infrastructure, cyber attacks usually could impact, the main impact of it is the final loss, financial loss. This is the most important factor for any cyber attack in the regular IT business networks. While on the OT, the impact is much more severe because we could have casualties, we could have death, injuries, environmental pollution, radiation, because such attacks are targeting critical infrastructures that they provide service or products to consumers directly, and most of the times to hundreds of thousands or to millions of consumers. So targeting a nuclear plant or oil and gas facility could also, to the addition to the death that it could cause as well environmental pollution, for example, or release of dangerous gases from a gas plant, spill some oil and cause a huge environmental issue. In addition to the example that we given for the water treatment plant. So the impact is much more than having some financial loss. Of course, such critical infrastructure operations, which runs 24/7, should not be stopped at any moment. So again, the financial loss is big, but it's not the major concern for operational technology owners. So we'll give a brief what is OT. OT are the components, hardware or software that is used to automate and control critical infrastructure process. So it's both, it's the hardware and the software. It's used in most of manufacturing and critical infrastructure facilities, oil and gas, shipping, logistics company, petrochemicals, nuclear, power plants, water treatment, food and beverage, and any other industrial manufacturing facility. All of those runs on automation or control process that need to be protected. The components are like field devices from sensors, valves, pumps. Those are controlled by something called controllers, PLCs, and RTUs that are used in different power plants and oil and gas industry. The whole process of such hardware is usually controlled by SCADA softwares, which is embedded softwares that runs on those machines and make the whole automation process possible. This is an overview of like the SCADA system or what the operators of the critical infrastructure facility can see and how they can manage, monitor, and check if there is anything wrong in the whole process. The main vendors who are providing the automation systems, which are controllers and the SCADA softwares, these are some of the top of them. We're talking about Honeywell, ABB, Yokogawa, Emerson, Siemens. And these systems, you can find it in any OT environment. What are the challenges that the OT operators and owners are facing in order to make their systems and assets and data secure? First of all, the operational technology environments used to be, years ago, air-gapped. It means each plant runs by its own. There is no connectivity required to head office. There is no reporting, remote reporting, or remote monitoring of the process. Nowadays, with the concept of Industry 4.0, the smart cities, IoTs, more connectivity is required. Someone needs in the head office, for example, to monitor and see how the process in the plant is going. It's smooth, it's efficient, lots of communication has to happen. And this mainly opened doors for attacks coming from corporate networks or business networks towards the OT infrastructure. So the first important thing is moving from air-gapped to a connected environments in the operational technology. The other differences in applying some security controls and defenses for the OT and the IT. In the IT cyber security professionals always are moving toward the CIA model, which is the confidentiality, integrity, and availability to protect their assets and data. While on the OT, the priorities are different. In addition to the safety, which is much more important than everything else, availability is very critical. We're talking about a process that needs to run 24/7 all over the years. Each few years only, they will open a window of few hours in order to make a planned maintenance. Other than this, the process has to go. So availability is a key. The other things that are different is the life cycle. OT controllers and workstations and the whole process, the life station of it, mainly it's 15 plus years. While in IT, we're talking about each couple of years, there is a major update and the technology and upgrades are happening. While in the OT, if the process is running, it has to be left running for so many years before any even minor update to happen. In lots of OT sites, you will find Windows 7 still, which is out of support and updates since so many years, are still running SCADA softwares and applications. We give some differences between why IT security and OT cybersecurity are different. To understand the behavior in the OT, OT is a static. We have this operator, it talks to this controller, it asks for specific parameters or readings from sensors or other field devices, and that's it. This same process runs for so many years. There are no changes, no additions, no moves like in the IT network. The action, once an incident is detected in the IT, usually is automated. Any alert or let's call false positive usually is investigated and some automated action will be taken. While the OT, as we explained, that availability is the most important factor, once we cannot take any action on any cybersecurity alert unless it's really very solid. Because you can take action to stop the process and find out later that it wasn't really a solid alert, and this will cause so much loss. Now, if you want to talk about how to secure the OT or ICS, the Industrial Control System Network, the first model that was released maybe more than 10, 15 years ago, and still it's in use, it's the Purdue model. And all the later on frameworks that released were referencing and based on that model. What this model made is just to classify the assets of the operational technology into levels. So for example, the field devices, sensors, valves, pumps are put as a level 0. Then the control process, it's a level 1, which includes all the controllers, PLCs. Then the operator workstations and other stuff put on level 3. The purpose of this is to start putting a limitation on communications between different levels. And this is what the other standards and frameworks issued by, for example, ISA 99, IEC 62443, National Institute of Standards and Technology, NIST, and even the local NCA regulations are all referencing the Purdue model and making zones or conduits between those levels that we explained from level 0 up to level 5, so that no equipments or devices in specific level should talk to the upper level without restrictions or a kind of policies or firewalls in between. Now, in order to secure the OT, we can still use some of the IT cybersecurity best practices, but it has to be implemented in different ways. Because we mentioned some of the reasons like the long life cycle of equipments. Here we can add there is no patching that is done on regular basis because of the process itself in the critical infrastructure cannot be interrupted. Additional matters also, the access from third-party contractors and vendors, remote access or physical access at site is something very frequent for the OT, where OEM vendors like Honeywell, Siemens, they need to access and do some troubleshooting and fixing systems. This also is something that is not available on the IT network. The first part, and also as referenced in the international frameworks, is before you can secure, you have to identify your assets and your components. So the first step in the journey of protecting OT cybersecurity is knowing your assets, is assets discovery or assets management, as we call it. After asset management, you can have a complete list details of your assets with their software, hardware, their even the vulnerability scoring of each component. You can then classify and make priority on the more important assets to start fixing the possible vulnerabilities available on them. After then you can start with the segmenting which is what we mentioned about zoning and making boundaries between different levels in the OT network. The third part is how to detect inside and outside threats for the OT network, where, as we said, it is a static environment in the OT. So any abnormal behavior or connection between two different connected should bring an alert because it's something that is unusual. The last thing is to have a proper incident response plan, documented. It has all details, how to do or how to behave in case a possible suspicious cyber incident is going to happen. And this is definitely including a proper backup solutions for all the critical OT workstations and servers. So just to summarize this, I mean, the protection, it starts with the asset management, asset discovery, having a proper centralized antivirus application whitelisting device control solution, a proper patch management solution that is approved from the OEM, and then checking the internal communications and behaviors inside the OT network is also very important since it is really a static and stable process. With this, I am done with my presentation, and please feel free if you have any question. Thank you.